Chapter 4, Energy and Matter, Part 2. Force. Energy applied to matter that causes a change in velocity. U.S. customary units is pounds force, and SI units is Newton. Force is the amount of energy it takes to make matter move. It can be pushed or pulled. And you can see in the picture, a pound on Earth and a pound is 1/6 of its weight on the moon. Work. Force multiplied by distance traveled. U.S. customary units is foot-pounds. SI units are joules and Newton times meter. Formula. Work equals force times distance. Work is force applied to an object at distance traveled. Work can be increased or decreased in energy. For example, work is a positive when you step on the gas pedal of your car. Work is negative when you crash into a tree. Sorry about that visual. Power. The rate of work is performed. In U.S. customary units, we use horsepower. In SI units, we use watts. Formula: power equals work divided by time. Power is the rate of doing work or spending energy, whether the work is positive or negative. A small amount of energy is used extremely quickly and can have a lot of power. A large amount of energy is used very slowly and could have very low power. Energy is used to apply force over some distance. Power is a quantity of energy used, generated, or transformed over time. Heat, cold, and temperature. Heat is energy released from the motion of the atoms that make up matter. Cold is what happens when you remove the heat being produced by moving atoms. Temperature is a measurement of the heat intensity. Usually temperature is given in Fahrenheit scale, Celsius scale. The words heat and temperature mean different things, so be careful to use the words correctly. Temperature scale. Perhaps Fahrenheit scale, Celsius scale, Rankine scale, Kelvin scale. These other two scales you probably or might not have heard of before. Rankine scale and Kelvin scale, they take the actual temperature that they feel at the time was used. So in Celsius, absolute 0 is 73 Celsius, or 0 at Kelvin scale. Here's two thermometers to show you the difference between Celsius, Kelvin, Fahrenheit, and Rankine. Ambient temperature, the temperature of the air surrounding an object. So in this case, a room is ambient temperature. No matter what the temperature is, it's just the room. Often used in reference to air-cooled condensing motors and other components. May affect the efficiency or trip safety devices. Ambient may not be consistent, especially outdoors, sunshine, rain, and snow. And let me explain this because I've lived in other parts of the country. In Las Vegas, when it's 40 degrees in the winter, and yes, it does get that cold in Las Vegas, it is a higher elevation than, say, something like Death Valley that's at sea level. In Las Vegas, when it's 40 degrees, if you're standing out in the sun, there's no reason to use a coat, and you will get sunburn. It's very warm because there's no humidity in the air, which allows the heat rays to get through the atmosphere without being slowed down by moisture. Where here in Florida, you can be 50 degrees here and be hot not because of the sun, but because the humidity in the air is keeping the moisture on your body. Entropy is a total internal heat of an object. When a substance changes at a constant pressure, the heat is generated. Empathy tells us how much heat and work was added when a substance grows, or as much as it is taken away when a substance shrinks. Specific empathy. Specific empathy is a total energy in a system due to pressure and temperature per 1 unit of mass in the object. Methods of heat transfer. It's important to know that heat transfers from one object to another. Faster moving hot atoms give up their heat energy to colder, slower moving atoms. There are three types of energy: radiation, the flow of heat through the air, examples, ultraviolet rays from the sun, heat from a stove or burner, X-rays from an X-ray machine, sound waves from your stereo, microwave, and from microwave ovens, radio, and laser beams. Yes, they do exist. Conduction, the flow of heat through materials, example, a metal spoon getting hot when it sits in a cup of hot coffee, your back muscles getting warm when you use a heating pad, melting ice in your hands, burning your feet by walking barefoot in hot sand or asphalt, a heat exchanger that uses hot fluids to conduct heat to cooler fluids without the two touching, convection, the movement of heat through gas or liquid, examples, air conditioning, central heating, steam turbines, car radiators using fluid, blood circulation in warm animals, shock waves coming from an explosion, convection ovens. Method of heat transfer. Radiation, heat transfer by heated X-rays, as we talked on the last slide. Conduction, a flow of heat through molecules of vibration. And convection, the movement of heat by using liquid or gas. State of matter. This is the issues that we talked about in slide number 7 about the ice cube being a solid, it melting and turning into a liquid, and then as it boils, it turns into a gas. And this slide talks about how the solid keeps its shape. Liquids have a defined volume but no specific shape. And it takes the shape of the container. Gas has no definite shape or volume, but expands to fill a container. Latent heat is the heat required to convert a solid into a liquid or vapor, or to convert liquid into a vapor without the change of temperature. Another way to say this is the quantity of heat absorbed or released when a substance is changing from one state of matter to another. For example, the ice cube sitting on a table, it will change a state using latent heat. Sensible heat is the heat that can be felt as energy is moving from one substance to another.